team. So I have here with me the student organization that is a self-driven, motivated student organization that has been formed. And it has a range of students involved in this team. And we are looking forward to see their objective is actually more goes towards autonomy of the robot, and it's really interesting to see what they have here. So I just let the RoboBoat student organization to continue. Thank you guys for the presentation on the mechatronic side. So go ahead, guys, you can take over and talk. Whoever wants to go, and then ask Carl to change the slides.
Yeah. Jack, can you get them first?
Jack.
So, sorry, adjusting that thing. Well, the next one. I'm Kyle Houchin. I'm the team lead for our RoboBoat for our student club here. I'm a mechanical engineering third year, and I'm doing a robotics minor. Go ahead, Jack.
Hi, I'm Jack McIntosh. I am the design lead, and I'm a mechanical engineer in the second year.
Our programming lead, Jonathan Gibbs, he's not here right now, but he's second year too. Portia.
Hello, I'm Elizabeth Fox. I'm a first year mechanical engineering student.
And then our other three members aren't here right now. And then
Eric was here a few hours ago. He's working on solving our research issues. So yeah. This team is very impactful. Yeah.
Yeah. Hi, I'm Hannah. I'm also first year mechanical.
I'm Nathan Petzel, and I'm a third year mechanical engineering student.
All right. So our team is broken up into three different categories. We have our building team. So that's the fabrication, that's choosing how the boat's designed. We have our electronics. So that's going to be any of the wiring, any of the safety methods that we need to put in. For example, a kill switch for the motors and stuff like that. And then we have our programming, which takes care of everything else.
All right, so currently we're on the hull design. We're going for a catamaran design with 4 motors, 2 motors on the side for thrusters and 2 rear facing, which we are still debating whether they should be able to pivot or not, but next slide. We have some mock-ups of our boat made in a software, as you can see on the top. Our current dimensions are 3 feet by 1.5 feet by 0.375 feet. And we're still also experimenting with some of the models. The program's not working as well as it should be, but it's given us a really basic idea of what we want. And we have printed out one of our models. Yeah, go ahead. All right, so we have opted to go with fiberglass, and we're going to use foam more for prototyping, and we are going to mold it. We're still debating which type of mold, reverse molding, regular, or we might actually 3D print a mold and put them all together. And obviously for the prototyping, we'll probably design foam and see if that works. Okay.
Yeah, so for our sensors for the bot, ours is mainly going to be focused around our LiDAR and sonar sensors. So we're going to have sonar sensors all the way around the rope, around the boat. These will give us more precise close measurements. So we aren't necessarily using the LiDAR as heavily when it's super close to the boat. And then we're going to use the LiDAR for the longer distance. The 2 cameras, we're going to use the vision processing in order to give us color data on the buoys so that we can get through the navigation channel and the landmine and stuff like that without hitting stuff. So those give us color data as well as more distance. And then our IMU is going to be there. So we essentially will cancel out any of the drifting patterns we get from wind or any of the wave movements that might throw off our LiDAR readings or our camera measurements. As far as the electronics, we're going to use a BagelBone Blue microcontroller for our main controllers. So this is going to handle all of the intelligent part as far as the mapping and handling the pathing and stuff like that. For our vision and our LiDAR, we're going to use the Jetson Nano to process that. For our 2 cameras, we plan to use a AI to quickly process the position data. So essentially we get a square around where one of the buoys is, and then a distance, and then a distance in X, Y, and Z coordinates. And then for the LiDAR, it's going to allow us, it's going to process those distances and give us chunks of where items are. And then for everything else, we're going to be using the Arduinos just because they're easy to use and they're really easy for a lot of components. Yeah.
All right, so Kyle covered a lot.
We just covered this. Yeah.
Yeah.
Skip it.
Um,
So on here, this shows our ultra sensor. Bottom left picture, our LiDAR, which we're going to be taking from the turtle bots. So that's bottom right, and then a picture of an IMU that we might use. Yeah.
So with all the sensor input that we should be getting from the cameras, the LiDAR, the sonar, we're going to like feed that into an artificial intelligence. So it'll be able to navigate through the obstacle course based on the color and the distance, as well as incorporate a senior design project from last year. So it makes an updating map of its location as it continues to work through, and that should help with not needing to have any manual input.
Are there any questions?
I got a couple. Oh, sorry about the feedback there. So the sonars, are those above the surface or under the water?
So these are going to be above the surface. Right.
So they're like finders, basically.
Yeah. So right now the buoys are mostly over the water, so they're going to be sticking out of the water by a decent amount of size. So essentially, these are going to be to detect those physical objects. There is a challenge that uses acoustic docking, where we might implement some underwater ones, which we have found some waterproof sonar sensors. But right now, we're focusing on just 2 or 3 of the projects or the challenges. So that would be the navigating through that channel, which is the windy part, and then the sorry, my brain's just failing.
Well, I mean, without the underwater passive sonar, you can do many of the challenges.
Yeah.
Because you can do the obstacle course, you could do the obstacle channel, you could do the obstacle field, you can do the speed.
Yeah.
You could even theoretically dock as long as you can remember where you were. Are you thinking of using anything like GPS to augment the IMU?
Potentially to begin with. We haven't really considered using it too much, just because within the range that we'll need the precision, the GPS isn't going to give us it accurately enough. So we might use it for general, but for the most part, we're going to be relying on more of a local system.
Okay. So, what do you have in terms of, so obviously over the next couple of months, you're building this. You're in South Dakota, which isn't known for being on a lot of water. I'm assuming there's some lakes nearby. Do you have access to like a swimming pool, or do you have, are you thinking of doing any mock-ups of the buoys? I'm pretty sure the rules describe exactly how they're built, so you can actually test a lot of this stuff before you go.
Yeah. We have access to a water tank here on campus that we'll be using for some of the thrust and sensor calibrations. And then we are working on getting access to the local pool so that we can do small scale testing. And then come in the springtime when we get more of a complete boat, we're going to plan to use some of the local lakes around here.
Okay. So, yeah, I mean, that's good, because because this is one of those situations where, especially because you're proposing to use the nano and basically a machine learning style algorithm or the current convolutional neural nets for your perception. If you train it in one environment and then like totally change all the backgrounds, it may completely fall apart.
Yeah.
So you kind of got to work with both the sonars, the cameras, and the LiDAR and all that, and see how realistic can we get, and then how general can we do our training, so that if we change to Florida, where the competition is held, it's, that may be completely different backgrounds, lighting, color of water, all those things, compared to maybe the lake you're using in South Dakota.
Yeah, no, that makes sense.
So just maybe something to think about as you're moving forward, is not just how do you build it, but also how do you test it.
Yeah, for sure.
So, yeah, no, cool. I mean, it looks like it's a good start for sure. Make sure there's a lot of emphasis on your programming. The computer science, I'll just give that as a hint. That's often where these things start to fall apart.
Yeah, for sure.
Yeah.
So good luck.
Definitely, that's Eric and John. We have two of our I think the student organization teams that still are not here, and they have been involved with the help of Colin, and I think the team is still growing, and definitely there's a lot of emphasis. Besides that, one of the members, I mean both of them, we have the Tuesday Thursday meeting that we are working on the broken packages of Alex's thesis work. So they're kind of at the same time that they're working on this, they're also getting training, and all team members are pretty much active on the programming side. So yeah, definitely, we will keep that in mind.
Cool. Well, thanks for presenting this to me. I appreciate that you guys have been pulling yourselves together, and it's really cool that you guys decided to go after it, because I think I was the one who suggested try the RoboBoat competition. So thank you for that.
Well, thank you, Martin. I did record the meeting, so I will share it with Ty. I did not send any reminder for him. And I actually am personally also interested and looking forward to see what's going to come out of the RoboBoat, both on the mechatronic and mostly on the autonomy.
Yep, cool. All right, well, I know it's getting late for you guys, so have a good evening.
Thank you. Have a good evening.
All right,
bye.
Bye, folks.
All right.